Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. And tonight we're going to take a look at using a special type of problem called puzzle problems to get your students to talk about math and justify their thoughts. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make those tough to teach, tough to learn concepts accessible to all my students. With us tonight are Tracy Matthews and Tim Collier. Tracy is a geometry teacher at McAllister High School in Oklahoma, as well as an Oklahoma Excel team member and head of the math department at McAllister High School. Tracy, it's great to have you with us tonight.
Thank you, Mike. I am super excited to be here.
And Tim taught high school math for 34 years in Oklahoma. He's an instructor for the Great Expectations Education Foundation, Teachers for Teachers, and is a regional instructor for TQt. He currently serves as a secondary academic design coordinator for McAllister Public Schools in Oklahoma. I'm pretty sure that Tracy and Tim worked alongside each other and together, and they are actually sitting next to each other tonight. So Tim, it's great to have you with us as well.
Thank you, Michael. I too am really excited to be here.
At this point, we're going to hear from Tim about some of the agenda items for tonight.
So our agenda is fairly simple. We're going to be talking about this concept of puzzle problems. We'll have a short introduction in a moment. We're going to talk about actually a project that Tracy and I have been working on now for 3 years and sort of walk you through our personal growth and the growth that we think most any teacher would go through to implement puzzle problems and justification, which is the last bit on our agenda.
Tim, thanks so much. And stick around to the end because tonight we'll be giving away to one lucky winner a TI graphing calculator of your choice. And that drawing will be at the end of the webinar. And Tracy is going to discuss our agenda.
Well, our expected outcomes tonight, we want you to go away with knowing how to implement puzzle problems in your classroom tomorrow without disrupting your lesson plan at all. We want you to be able to empower your students to think mathematically through their problems using just simple puzzle problems that you can find on the internet. We want you to be able to change the words of a problem to make it a more cognitively complex task, and to be able to evaluate your students' justifications using a rubric, and to foster mathematical justification and modeling using TI-Nspire technology.
Tracy, thanks much for those expected outcomes. Tonight we'll be using the chat window to send general messages. Feel free to ask any questions of Tim or Tracy using that Q&A window on the right side of your screen. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. All right, Tim, I am giving you control. Feel free to share your screen.
Okay, so we have puzzle problems. We see this as a path to student justification. Again, this is Tracy and I. Again, you already heard that I taught math for 34 years at various levels. And Tracy, Johnny come lately, didn't get the calling until later on. She's only been teaching for 20 years, so she's a youngster in our.
All right, on the next slide, we're going to have a little puzzle problem for you. We're going to give you 45 seconds to type your response in the chat. And when the timer hits 0, that's when we want you to actually submit your answers. Some of you may have used this in some of your virtual classes. We call this a waterfall chat or a cascade chat. So go ahead and type your responses, but don't hit send until the timer gets to 0.
Okay, here we go. 45 seconds.
Which one does not belong? Justify your answer.
Well, I think I know which one I would pick, Tracy.
Well, I have mine picked out too.
I don't know, though. Maybe I changed my mind. I see something else I didn't see when I first looked.
Well, can you justify your answer?
Well, I think I can.
All right. Well, then you could actually justify 2.
But what if it's not right?
That's the beauty of which one doesn't belong. There is no right answers.
Wait, how can there not be a right answer? This is math.
I know, but how else can we talk about it if everybody doesn't feel confident about giving their answer?
So let's get to that chat feature and see what there is to see because time is up.
There you go. All right.
Are we seeing our chats come in?
Tim, I'll just jump in real quick. Just as a reminder to everyone who may not know this, whenever you're chatting, please send your chats to everyone as opposed to another choice might be all attendees. So please send your chats to everyone. That way, Tim and Tracy get a chance to see them.
Okay, thank you, Mike. Oh, I see somebody chose one that I chose. Oh, for a different reason. Nice. The heart, fewer points.
Wait, you're saying that they can have a different justification and still have the right answer?
I chose the heart because there were no straight lines.
No, I thought you would chosen it because it's pink.
I know. It's lots of stars. Lots of stars.
Lots of stars. Why are people thinking it's the stars? Oh, the lower right hand is not shaded. Elizabeth, you thought like I thought.
That was a tough one for me too. I was like, going back and forth.
Okay, the whole point here, a puzzle problem is an accessible question.
Oh, two shapes. Oh, I could go on here all day.
Oh, someone says two shape.
Yeah.
Okay, all right, all right. I would love to spend the next half hour just on this question because, oh, dodecagon. Yes. Okay, no, we got to go on.
Today's presentation is a reflection of the ongoing project that Tim and I have been working on for a while. So this presentation is actually organized that follows our growth through this process.
Now, certainly, it's going to be built around puzzle problems, and you're going to find puzzle problems sprinkled through the entirety of our presentation this evening. If you're looking for some to use, they're certainly going to be available to you. So again, just to give you some sense of who we are, we spent, well, actually with TI longer than 7 years, but we've been every year for the last 7 years involved in a Gear Up grant with TI training with a couple of national instructors, Doug Roberts and Sandra Hocutt.
We've also attended and been presenters at T-Cubed International Conference and saw some great sessions there that have influenced our journey.
And hopefully we presented some at least average sessions there.
Hopefully.
We both attended the Teacher Leader Cadre in 2018. And out of that, I was able to become a regional instructor. Tracy, well, not having a math degree, has not been able to apply for that.
We both became members of the Oklahoma Excel, which is a state organization here, and we're going to talk more about that in a minute. But so this is the journey that we took to get where we are right now.
So let's talk about Oklahoma Excel. It's a statewide networked improvement community. So we are a group of teachers from brick and mortar and virtual schools, from large schools and small schools across the state of Oklahoma that have taken up on ourselves to study this business of student justification and what it could look like in a classroom.
So we implemented, you come up with a change idea, and the change idea for this network improvement community were puzzle problems and using them as a path for student justification.
So those puzzle problems, we administered them with our students. They're very accessible. We'll talk about that in just a moment. But the process here, just so you understand the process for our project, was we collected data in a plan, do, study, act cycle that was 6 weeks long. That data included student surveys as well as some graded justifications according to a rubric that we collected across the state, gathered some reflections from that, and were able to refine our process.
We're now in year 3 of that, so we've been doing it for a little while, gaining a little experience.
So the question is then, why do we care about student justification? And is it worth spending this level of effort putting together?
So I guess the question here is, do you know, how do your students know if their answers are correct? And why do they know that? And justification provides a deeper understanding of the mathematics. It actually prompts students to question whether or not their process is correct and how they know their answers are correct. They're not just mimicking their teacher.
So it's not just a function of following an algorithm, but it does promote actual analysis of mathematics. And the second step of revision that so few high school students are willing to go through to know that they know that they know why their answer is correct and what sense it makes in a larger context.
This justification leads to the democratization of the knowledge. It takes the power out of the teacher's hand and really shares what drives the classroom with all of the members of the classroom.
You know, even as a 20 plus year teacher and having been involved with TI pedagogies for a long time, I believed and I was moving toward being a student-centered classroom. But until we entered this project, I didn't understand the breadth and depth and the nuance of having a student-centered classroom.
Student ownership of the mathematics increases when students are justifying.
And the teacher can see and hear what students are thinking. What a wonderful formative assessment tool to be able to just have a glimpse inside their noggins and see what's going on. So this is sort of well, not sort of, this is the driver diagram that our project used to decide how to move forward, having identified justification as something that we believe is important. After studying this aim carefully, we understood that if we're going to ask students to actually justify their thinking, that we're going to have to change some student mindsets and beliefs and shift their experience. So many students, and I think especially in many cases, honor students arrive in high school having learned to play school really well. And they wanted to follow an algorithm, get an answer, and feel good about themselves, but to be asked to explain how and why their thinking brought them to a particular place made them uncomfortable. Certainly, teacher mindsets need to shift as well.
You have to be willing to believe that your students can do this type of work, that they can justify their answers. And so there was a need to change teacher mindset as well.
I know early on in this project, if I'm honest, I didn't believe, it wasn't that I didn't believe that my students could justify, I didn't think that they would.
Which leads us to teacher skill and classroom instruction.
It does ask us to change our particular skill set and how we think about instruction, including classroom management, what a student-centered versus a teacher-centered classroom ought to look like. And that landed us at puzzle problems. We needed something that was accessible, that was actually doable, and relatively narrow so we could collect some data and actually refine our practice as we went.
So we use these puzzle problems as our vehicle or on-ramp for students to think deeply and start to justify their reasoning. We didn't want teachers to have to make a big change in their curriculum. We wanted to start with simple problems like the one we did at the beginning of this presentation and just use those to change the culture and climate of our classrooms. We wanted to take the focus off the answer and put it on the process.
So students have the opportunity to have a vehicle for continuous improvement. And it turns out that we as teachers also were afforded this opportunity for continuous improvement. So what are puzzle problems?
Well, we used short problems that will allow students just practice to think mathematically and not have a rigid structure to do that. We wanted to include all learners and even those that may feel disenfranchised because they weren't sure that they had the right answer.
That business of having a right answer is a big cultural shift for students. So when? Well, puzzle problems can be short, 5 to 15 minutes in length. They can be added wherever they make sense in your lesson.
They can be your bell ringer, they can be your exit ticket, or you can actually embed them into your curriculum.
Now, I know that in fairly short order, you, Tracy, abandoned that 5 to 15-minute window.
I did. Puzzle problems became so popular in my class that students wanted to do them more and more often that I carved out 45 minutes a week to do just a deep puzzle problem where they got to present their ideas, argue, and all of that. They love it.
So you said they love it. You're saying that your students, you teach 9th and 10th graders, and they're willing to actually step up and take part in something that's this challenging?
It's the favorite day of the week.
Wow,
Mondays. Puzzle problem Mondays.
that's a pretty big ask there. Their favorite day of the week.
So we start with these low floor, high ceiling problems, accessible to all learners. That was the biggest struggle for me, was to change the culture in the classroom. We all have students that just want to sit there and not participate. And then we all have students who you can't shut them up. So in the student growth, we were looking for a vehicle to get these students to start talking about math without the burden of being right.
So again, we're asking students to think about the process. We've chosen problems, these puzzle problems, in such a way that there really isn't a right answer. It's just a vehicle for them to notice what's different, or to notice a pattern, and to express what they understand about it in whatever way that they can. In whatever way that they can is exactly the right way.
Exactly.
Our puzzle problems that we chose in Oklahoma Excel were these 3. Which one does not belong? You did one of those at the opening.
Yes, we did.
Always, sometimes, never, which we'll get to see one in just a moment, and some would you rather questions. These are where we began as teachers developing our skill set in designing these puzzle problems.
And it wasn't too demanding on a teacher. These are easily found on the internet. So it wasn't like, when we got started, it wasn't a big burden on us to come up with our own puzzle problems.
So here we go. Let's do another. Which one does not belong? Please pop your answer in the chat and see if you can justify it. Tell us why you think that one doesn't belong. Well, I think I know which one I picked.
Oh, yeah, there's one that just really sticks out for me too.
But wait, what if mine's different than yours?
I often have students who feel like that they can't just choose one. Miss Matthews, what if I can build a case for every single one of those? And so that's what we started doing. We started building a case. Give me a justification for all of them.
So you're asking your 9th and 10th graders to justify every one?
Sometimes.
Oh, check out what's going on in the chat.
Okay, so we've got the parabola. That was my choice too. The quadratic. Yeah, it just stuck out to me. Lower left does not belong. Ooh, okay.
The lower left.
Yeah. Top right. Yeah, not
Top
linear.
right.
Yep, top left, positive slope. That was another one that.
Oh, yeah. I noticed top left. I noticed top left because it's the only one that's greater than or equal to.
It's right. The only one with a solid line.
Ooh, but bottom left is the only one that's less than.
Again, this is a perfect problem for building a case for all of them. And listen to them, to the great math discussion that your students get into. They will argue about why theirs is right. Almost battle over which one is the one that doesn't belong.
Well, Jim, we're glad that you love this, because we love this too, dude. It changes how students interact with mathematics in our classes. The point that they have a vehicle. I mean, this is not all we do, of course. There's still some traditional work going on, but it starts to permeate everything that we did. It permeates. All of a sudden, there were all these opportunities that just presented themselves to do puzzle problems in the course of the curriculum after we learned like what they look like, how to conduct class around them. And also we were able to engage students that were different, the ones that were creative.
Right. Those students that don't necessarily think of themselves as math people, okay, they add so much to the conversation. And then they kind of realize that, hey, I may be a math person.
And you know what? Those students have the ability to think things differently. to represent their thinking in ways that are maybe outside the norm or not algorithmic in any way,
Yes.
but are still good mathematics. And they were able and willing to join into a discussion when they didn't have to worry about not being right.
We have had very heated discussions or arguments in my class over different puzzle problems. Answering someone in the chat. Yes, they can be very passionate, and nothing is more exciting than when kids get passionate about math.
I remember very vividly visiting Tracy's class one day and having two students in this passionate argument over exactly the same thing.
Yes, they were saying the exact same
They
thing.
hadn't come to the place that they understood that they were arguing the same point yet. They did get to that point, but Tracy did not intervene and didn't have to, because in the course of their conversation, they figured out mathematics for themselves. Puzzle problems. What a wonderful thing. Let's look at a different kind.
All right, so here we have a would you rather. This is a favorite one of mine. I use it every year. It really does address not just math and how we use math in the real world, but also brings into play some value judgments or real life choices.
Oh, certainly. But wait, a problem like this, how does math involve value judgments? Isn't math just math?
Math is just math, but often the math helps us make a decision. And not all of our decisions are strictly mathematical. And that is something that the kids realize. But they made their decision based on the math and other things in their life.
So look at this question. Restaurant A pays 18 bucks an hour, but I'm not getting any tips. Restaurant B pays 10.50 an hour, but tipping is encouraged. Tracy, I don't see enough information on this thing to even start the question.
And some of the people in the chat are like, well, how much time are you spending at each place? Right? What's the opportunity to work more for server on one side versus the other? So when I'm doing this puzzle problem, this is all I give them. And I'll have some that'll get started on it right away. And then they'll say, Ms. Matthews, I don't have enough information. So we talk about how you might have to make some assumptions in order to, move forward on your problem. I had a student say, Ms. Matthews, can I look up what the average tip per night is on an average restaurant? I think he ended up looking at IHOP, what the average tip was for a server at IHOP per night. And I let them look that up. I mean, that's what we do.
Well, that's how mathematics rolls out in their day-to-day lives, right?
Absolutely.
What do I want to buy a new car? Do I want to buy a house? Can I afford to get married? Those questions don't come with all the numbers that you need built into their question.
Exactly. And students need to think about, where can I go to get this information?
But that thinking, the thinking of what information do I need, is the beginning of the mathematics.
Yes.
Well, Tracy was actually did this problem in her class the day before yesterday, and was gracious enough to share a couple of responses from students.
So I shared this response with Tim because I was so very excited about it. I sent him a picture of it in a text and said, oh my gosh, look what my kids did in class today. So we are 3 weeks in of school, and these are sophomores that I've never had before. But just doing a little justification every day, puzzle problems on Mondays, I had some students come up with multiple representations of this problem.
So you didn't prompt these students to give multiple representations?
I did not. You saw the slide that I gave them, and all I did was respond to, Ms. Matthews, can I go here for more information? Can I make assumptions? Yes, that's it. That's all I did.
Well, Rebecca, in answer to your question, where do you find these problems? Most of the problems you've seen tonight, we gathered from the internet just by searching the names of those questions: always, sometimes, never, would you rather, and which one doesn't belong. There are some printed volumes out there, but there are some websites devoted to, and many websites devoted to these kinds of questions. But again, it's how you use the question. It's not the value of the question that becomes really important.
If you Google, would you rather, this question is going to come up.
Yep. I hope that's helpful to you, Rebecca. So in this question, I see restaurant A and restaurant B. Which one's the right answer, Tracy?
Well, that's one of the things that we really talk about in my class. These were done in groups of 3. So one student may decide that they would prefer restaurant A. About 1/3 of the students for the whole day chose restaurant A. 2/3 chose restaurant B because they felt like they could prove mathematically that they could make more money at restaurant B.
So what was the argument for restaurant A?
Most students that chose restaurant A wanted that reassurance that they knew exactly how much money was coming in and it didn't depend on anything else.
Oh, I see.
So they also pointed out to the people that chose restaurant B that it wasn't a consistent stream of people that were coming into the restaurant. There was mathematical mistakes. You're only having one person eat by themselves. There should be at least, 2 people eating. Most people don't eat by themselves. So it was a lot of great discussion. It is great to just sit in your class and listen.
So again, the point is we're having students think things through and doing mathematics in a very sort of visceral way,
Yes.
a very organic way, alongside the algorithmic way that we would normally present math in a traditional thing. Of course, I've been 34 years in the business, so that is the state of mathematics teaching for old folks, I guess. Back to the chat, there is not a list of these problems currently on the TI website, but we have hopes that that's something that could exist. How do you get people to start? I mean, how to get kids to start thinking this way?
So we found this online when we first started doing justification and puzzle problems in our class. And we hung these anchor charts up near where our kids do these puzzle problems. And we just found this online. And it was a reminder for our kids of how to justify their work. I like this one, especially for younger grades.
Right.
I will mention that in our Oklahoma Excel, we have grades from pre-K all the way up through upper level math. So this worked really well for the younger grades.
Of course, to be fair, this was also us trying to figure out how to make this go.
True.
We had to work it out, like how to change our view of classroom management. The directions given here were something for the students to get hold of. Now, we moved away from this fairly quickly as a project and wrote a rubric.
Right. I don't even start doing a rubric with my kids until they've got a few puzzle problems under their belt. Just so that I don't have the very first one, but I mean, like a week in, and then I start evaluating their justifications. So because we are collecting data about student growth, we needed a tool to use to gauge that. And so Oklahoma Excel came up with this rubric, and our team members sat down with several sample student justifications just to be sure that we were scoring them the same. And this really helps me see that my kids are doing better on their justifications.
Of course, this was for us to collect data with, but it's also a vehicle through which we can give students feedback about what their justifications look like.
Right. One of our team members just puts this rubric right on her paper for her justifications.
I know this was on the first page of the TI documents that I sent out to the handhelds with puzzle problems in them. The first page was the rubric. It didn't look just like this because of the nature of the handheld, but certainly this was the first thing that students see. My AP Calculus friends out there, is justification a big hairy deal? Yeah, it turns out to be, but making arguments or understanding what it is or why it is that you made a particular move in a problem is pretty important. Please note a couple of things on this rubric. So a justification question could get 0 to 4 points, but notice you could get 3 and still not have figured out the right answer.
Right, because it's about the process.
It is about the argument and getting kids to understand what they're thinking and to give the teacher a glimpse of that as well.
What they got for their answer, how they got the answer, why they chose that strategy is my favorite question.
Let's have a look at another puzzle problem right quick. This is going to seem a little less exciting because it looks more like a textbook question, but turning a textbook question into a puzzle problem is very doable. Have a look at this one. What do you think? Always, sometimes, or never?
So this was an actual problem that I used in my class. And then they had to choose, which they do. A lot of textbooks have you choose always, sometimes, never. And then, you know, on the textbook, it'll say justify your answer. And most of the time I would not get a justification at all. So they had to attach a notes page to, or a geometry page or whatever to justify their answer.
So here we go. So students had to choose always, sometimes, or never. Go ahead and put what you think in the chat. Is this always, sometimes, or never? Well, wow.
There's some sharp people in this group.
There really are. Maybe we should be listening.
Right.
Anyway, so let's carry on. Here we have some sample student responses. We would like to think about how we scored these using the rubric, just to give you a sense of how that might work.
So the question was, two triangles with the same perimeter are congruent to each other. And this was a great response because this student, who obviously got the answer wrong, said because congruent triangles must have the same perimeter. Well, that's true. Congruent triangles must have the same perimeter. But they didn't look at it from the point of triangles with the same perimeter must be congruent. So this gave us an opportunity to go back to logic and conditional statements and the converse. So this prompted great discussion in my class.
So you were able to capture the student's screen, put it up on the projector, and have them talk through their logic.
Yes, absolutely.
And all of a sudden, we had students talking about what's going on.
And they do that. They say, no, that's not right. And of course, you know, you're using nobody knows who that is. And and then they talk about, you know, you looked at it from the wrong direction, and then they start saying conditional statements, and it just makes your dialogue so rich.
So, I mean, here we have, you know, the bones of a decent argument. They have the parts here. They got a couple of examples. Of course, they did argue the converse of the actual question, which landed them a 2 or a 3, depending on how, you know, how demanding you felt that you should be about.
So from the chat, the criteria of having the same perimeter came before the requirement of congruency. But I don't have to say that in my class because my students are saying that to each other.
Let's look at another.
All right, so here's another response to the same question. As you can see, I got no justification on this answer or on this response. So the score was a 0. And you just have to encourage those students to, you know, okay, well, why do you feel it's always? Tell me about what you're thinking.
But even if the student had chosen the correct answer on the justification part, they still would have gotten 0 points because a right answer isn't sufficient without making clear what it is that you're thinking.
All right. You talk about it.
So here we have, again, another student response. This person said sometimes. It looked like the people across the country agree with sometimes. Mm-hmm. But look here, we have several things going on. We have the student arguing that, well, here I have 2 triangles, each of whose perimeters are 30, but look, they have the same perimeter, but they're not congruent because the corresponding sides are not congruent.
So they gave an argument for both sides.
But then we also have an opportunity or an actual congruent triangle that must have the same perimeter because, of course, both would add up to 30. This would be given a 4 out of our rubric.
I'd say in most classes, I have a wide range of justification quality. I always have that student who's hitting that vocab as hard as they can. And it takes a while to train your students to be able to do that. So this was a student who I try to get my kids using that geometry software on their TI handheld as soon as possible. And they opted to justify using an image, one showing that, you know, in one case, here's one with the perimeter of this much, same perimeter, but it looks completely different.
So here we have a pretty decent justification, but not quite as clear as we wanted it to be. We kind of, it said, but not be the same length. Again, we'd like to have a little more clear verbiage here. And of course, there wasn't an argument of what if you're going to have sometimes, that means there have to be some that meet the requirement, some that don't.
Right.
And we only have an example of those that don't. So the bones of a good argument here, some good representation, but not a 4.
And then we get, some responses that are, because when they are the same, they're congruent. Well, that's not wrong, but it also isn't very clear. So it goes back to the rubric. Is your justification clear? Can you understand? Can you understand it? And there probably should have been some use of some better vocabulary in here.
Well, this problem could have been over on the whiteboard, drawing some triangles, labeling them, doing some arithmetic, and gotten a lot more points out of this. But I mean, you kind of see the bones of some thinking, because when they're the same, they're congruent. But I don't know what they are. I don't know what they are, and it's even though the right answer, not a good justification. So again, asking kids to think that through. Um, I made the mistake early in this project of doing this kind of work where I had sent kids stuff on handhelds or on paper and asked them to work singly. We're going to see as we continue to grow how that changed.
So we grew as teachers in this process. We started with which one doesn't belong and would you rather, and we use those to build culture in our classroom. We use that to get all students talking and all students feel like they are math people.
So, John, can these be used with SPED kids in 9th and 10th grade? Absolutely.
In fact, they just love it. It gets them involved. It gets them where they feel included in what's going on in the room.
To be honest, I think those students love this process way more than the AP Calc students.
Yes, your honor students tend to not want, you have them, they don't want to show their work. They know it's the answer. What do you care? I know it's the answer. It sometimes can be the toughest ones to get to justify. But you give some of my SPED kids a marker and an opportunity to show what they're thinking, and they will let you know.
So problems don't necessarily need to come directly from your curriculum, as the ones we saw earlier. What the first one probably didn't fit into either of our curricula. Yeah. Still had value. The point of those kinds of problems are building culture.
Right. Eventually, I did want to start moving into something that was more curriculum driven, especially if I was going to give a little more time over to it. But that doesn't mean that you have to do that, but you certainly can. In fact, you have a really good example on which one doesn't belong for upper level math.
Oh, that's true. For me, always, sometimes, never questions. And I'm sorry, which one doesn't belong and would you rather questions tended to be outside my curriculum. But there's certainly in calculus or even in algebra, a would you rather question. For calc, it would have been about, would you rather calculate the volume of rotation using the cylindrical shell method or the disk method? Or in algebra, would you rather solve this quadratic by factoring or completing the square of the quadratic formula? The would you rather is asking students to write down, to express what they know about each of those methodologies, and thus be able to see the nuance for themselves so that they can make good decisions.
Yes. Okay. Looking at the chat. All right.
So the point is to encourage students, however you can, to build that culture, to build the mindset of talking or writing or sharing about what they're thinking. And those questions that really don't have a right answer are a wonderful inroad into that.
So at this point in time, we started thinking, what can we do to make this go further? What can we do to carry it on a little more?
So honestly, I was a little slower on the trigger than Tracy. She at T-Cubed in Chicago made the connection between puzzle problems and the pedagogies that we had been studying with TI training for the previous 5 years at that point. It took me a little longer, but absolutely that light came on. We were a part of a grant from a local college, a Gear Up grant where we got 5 years of training. That grant expired, and then they got another grant that we were going to be part of, but our students weren't yet. We did have the opportunity to have a little bit of grant money to spend on PD. So we were able to hire Doug Roberts, a national instructor, to come spend several days with us. And he introduced us to the idea of cognitively challenging tasks.
So Tim and I had spent many hours talking about how we wanted the culture in our classroom to change. We wanted to be student-led. And so we talked to Doug about this, and he goes, I think that I can help you. And so this was, again, part of our process to move from being the sage on the stage, as they like to say, to a more student-centered classroom.
And of course, we were wondering, how do we go about finding these kinds of questions?
That was the big struggle.
I'm sure that people in the chat have, I know at least one person in the chat asked that. So our response first was, well, let's take the questions that are already in our textbook and make them into cognitively challenging tasks.
So here's an example of a pretty straightforward word problem out of a textbook. If you take a look at this problem, you can see it's a Pythagorean theorem question.
Right. So 2 miles east, 4 miles south. Yeah, this is going to be just an algorithmic question where teachers would, or students would go to the quadratic form. I'm sorry, the Pythagorean theorem, not the quadratic formula. I shouldn't read the chat and talk, should I? What if we did this?
What if we rewrote the question and took out the numbers? Except for we gave them here the hypotenuse, and then we changed it to how far could it be from his house to the store? How far could Trisha live from the store? So it's more open-ended.
More open-ended, certainly. So the wording of the question implies that there's not a right answer. There's only one number. Well, I guess there's a 52, but it doesn't count, does it?
No.
Only one number here. Students began to think about or had to attack this problem a little differently. Now, we also needed to think about not only where these problems come from, but how our classroom culture had to shift if we were going to continue in our growth and the students' growth.
Did we have some? Oh, no. Okay. So sorry, I'm having trouble reading the chat also. So one of the light bulb moments that I had after going to see Dr. Lillydahl at a T Cubed was his research on vertical non-permanent surfaces. This changed the culture in my classroom. I cannot tell you how much my kids love to go to the boards. You saw some of the boards earlier, some pictures of my kids at the boards. If you haven't used this technique in your classroom, it is very, very powerful.
So, having learned to write better questions, we now addressed the culture in our classroom using these non-permanent vertical surfaces. So again, we're talking about whiteboards, chalkboards, windows, whatever, where students can write on something that everybody else can see that's erasable. Dr. Lillydahl has shown that the time it takes students to make their first notation is significantly shorter. Their persistence, their discussion, their eagerness to participate goes up. You'll see if you read his book that it looks like the optimum size for this is 3. We impose rules where the person holding the marker can't write anything except what they're told by another student.
And if they want to talk, they have to pass the marker to somebody else.
Certainly, this was a game changer for me, getting students up out of their desk and talking to each other in small groups and then across to other groups about the kind of math that they were working on.
So this got me thinking. Of course, I was doing this and then COVID hit. And so I was sending kids to the boards and I was supposed to be, keeping them socially distanced. So then I got to thinking about the TI tech that's in my room right now. we used it for discovery. It's such a powerful tool for getting kids to see mathematics. That's when I came upon the idea that they can use it to justify. If I can teach them how to use that handheld, they can use that to justify their thinking as well. And then I can make them present it on the board, and they can present it to everybody from their seat.
So certainly here is that same Pythagorean theorem question we were talking about a moment ago. Of course, students, you would expect them to build a triangle. There's enough information there to know that this is a right angle. There's the hypotenuse. Hypotenuse of 5. This is screaming out.
Yeah, my students would, every one of them would have drawn it. That's why, I tell them, did you draw it? Did you draw it? So we have a couple sample student responses.
So certainly we end up with the kids who said, oh, that's a 3, 4, 5 right triangle.
Right.
But remember, the question wasn't what is the distance from John's or Trisha's house? What could it be? Of course, somebody else did a notes page instead. But again, it's the same kind of thing. Some groups in a class are going to read the question carefully and go past that. If not, you may have to prime them and just let them know that it's not 3 miles from John's house nor from Trisha's house to the store. What other distances could be possible? So not 3, not 4, not a 3, 4, 5 right triangle. What could happen? Well, we had some students here that thought, oh, I'm going to take 3, 4 and take a little off 3 and add it to 4 and see what happens.
That kind of gave us an opportunity to talk about accuracy. The students wanted to argue, did we start measuring from his door? Do we measure from the mailbox? And we, real world. We were able to talk about real world situations.
Oh, all of a sudden we have, well, students doing this whole problem way differently. What meaning do these numbers have in the context? And when students can give meaning to the problem in context, then they are doing mathematics. So all kinds of good questions to be asked here on this kind of slide. What do these numbers mean in the context? What happens when one of them is negative? Does it make any difference?
Once you've taught your kids how to use their handhelds and start pushing them to use it for justifications, they start looking for different ways to represent problems.
And when they do, they come running up to you, Tracy, and say, Miss Matthews,
can I show you what I did? Can I show you what I did?
And they're thinking about this through. Oh, could John live at the store? What does that mean? Anyway, all different kinds of ways that students can leverage TI tech to justify their thinking. Next for us, as we started thinking all of this through and trying to get students to change the way they thought, was Dr. Annie Fetter's what do you notice, what do you wonder kinds of questions.
This changed the vocabulary in my classroom.
It changed how I started my classroom. Let's look at one. In the chat, what do you notice? What do you wonder?
Ooh. How many groups do you see?
How many groups do you see?
Chat, how many groups do you see? So I see 5 groups of 2.
You see 5 groups of 2?
Mm-hmm.
You see, at first glance, I saw 2 groups of 5.
Mm-hmm. Okay.
But I could see that someone could say there's 2 groups of 4 and 1 group of 2.
Yes.
Again, getting at students, how students are thinking about number, how they're thinking about counting. Let's look at another one real quickly.
All right, what do I notice about this one? I notice that they're all vertical on the top and they're all horizontal on the bottom.
Wow, I wonder what I wonder. I know what I notice. These are all congruent. Ooh, look, 4 widths must be the same as 3 lengths.
Nice.
Wow. And they could be Mario bricks for sure. But I wonder, does the length and width, does that apply to the big rectangle as well? Lots of great investigation here. Here's a different kind.
I love this one.
I have to admit that as a younger teacher, I would have built a mini lecture around this and tried very hard to point out all that was important on this page. But having introduced students to puzzle problems, to justifying their thinking, to talk about what they see and what they understand, starting that, back to the chat, the area under the curve, starting that lesson not with a lecture, but with students. What do you see in this picture, and what are you wondering about?
I believe that when you did this in your
Fish
class,
and I.
you actually said that all of the things that you would have tried to point out to your students all came about just from the notice and wonder activity at the beginning.
Very organically, some student, they were in pairs, they were on non-permanent vertical surfaces, writing down on a T-chart what the pair noticed, what they wondered. They pointed out every important thing and some things that I've noticed about what could have come out of the lecture. And at that point, it was so easy just to formalize it once they saw what was important in the picture.
It's a very powerful tool. My students already know what I'm going to say is, what do you notice? And then they kind of mimic me. What do you wonder?
Oh, yeah. Well, it does become a thing, but it does get at this. Well, I guess now it's a 20-year-old article. I hope those of you in the chat were born at this point. But for those old people, 2000 wasn't that long ago. Go look up this article. Never say anything a student could say. That business of notice and wonder is giving students the voice, making our classrooms student-centered. When they come in expecting to talk about what they see, what they think, what they understand, and only having the teacher formalize it as necessary, it changes the game.
So what's next?
Oh, our next natural step. Wow. Our next natural step. Maybe we need to ask a question.
All right.
Our time is running short. Respond to one of these in the chat, if you will. Let's give you not much time, 30 seconds. Mathematics devoid of meaning is empty. What sense do you make of this, or how does it make you feel in light of your teaching?
You can answer one or the other.
Or both.
Math without purpose is vain. I like that.
Vanity, vanity. I've never thought of myself as a vain math teacher, Tracy.
But I that makes sense to me.
It does.
It's, it must have purpose.
Math is not just numbers. In fact, numbers are just some of the tools that math uses, right? Ooh, it's got to make sense.
Mm-hmm.
Well, that's kind of where Tracy and I have landed. That students need to be able, people need to be able to make sense, to make meaning out of all these algorithms that they've been learning since elementary school. Ooh, math is what you make it. So our next natural step is, we believe, that of mathematical modeling. We learned what modeling was as it was defined here in 2016 by this study. It's a process that uses math to represent, analyze, make predictions, or otherwise provide insight into real world phenomena. The point is that math, though it does exist in and to itself, the problems need analysis, need to have some basis, some context in real world or something close to the real
Math
world.
doesn't take place in a vacuum. It doesn't just take place in my room. It takes place in your life, in the real world, and students need to make that connection.
And I noticed I have a quote from a student written on the classroom wall back in my old classroom that says this process made her see her world differently, and she was never going to be the same.
Oh, wow. That's amazing.
It is. So we know, having gotten a glimpse of the 2026 NAEP study, we know that modeling is going to be part of their prescription for how math should be taught and where math teaching should go in the next decade.
Future standards will be including, I believe, a really strong modeling.
We know for sure in Oklahoma, the next iteration of math standards is going to be built around this business of modeling. So again, going back to our project drivers, this business of getting students to justify, puzzle problems are important. It's a great inroad, but getting these other skills met is going to be a function of modeling. So modeling is sort of at the top of the pyramid of problems. We all started in elementary school doing computation and counting, some word problems. To be honest, in my own classes, I probably hope to get to problem solving, but we've gotten lofty, Tracy. We're going to model.
Yes, we are.
Let's take 38 seconds and look at a hook to get kids to model. Of course, we're talking about how many packets of sugar in that 20-ounce soda. Uh, Again, this is sort of built around those 3-act math processes that were made famous by Dan Meyer, but are done by hundreds of other people. That those roots of modeling, those roots of puzzle problems could easily be moved into these kinds of questions. Give us a guess that's too high, one that's too low. Let's start. What do you need to know? How do you find those things that you need to know to be successful answering this question? Obviously, you can see how this unfolds. I really only wanted to talk about this because look at this student, a high school student who didn't have a great deal of algorithmic skill.
I would like to point out that this was a SPED student.
But look, did this person understand enough mathematics to solve this problem and get a good answer? I love it. I mean, maybe no multiplication much on the screen, some drawing and counting.
Yes, I'd like to point out that in the chat, somebody said the kids would Google it, how much sugar was in there. But the question was how many packets of sugar was in there. So it wasn't something that was easily Googleable, non-Googleable. Certainly they could Google how much sugar was in the soda bottle.
Oh, sure.
And when they identified what information they needed, that information was given to them. But they had to identify what additional information they needed.
And certainly, we do live in the world of Googleability.
Yes.
Most any question that's been around for more than a minute, someone's going to have posted somewhere. But I do think that we need to continue to push the envelope of the kinds of questions we ask. Of course, this was intended to be an introductory level question for teachers.
Yes.
To get started with this modeling process. Of course, our time is running short, but to get to the modeling cycle, it is pick a problem, whatever it is. Let the kids pick the problem. Let them develop however they can to formulate an approach to do the computations, to interpret their computations in light of the question, and then to go back, as we said in the first slide, and validate that. How do they know their answer is correct? It's either start over or report. Well, I hope that, wow, Howard went so fast.
I did.
We'd like to leave you with these thoughts by Ruth Parker about what I used to think my job was and what I understand my job to be now. It's about looking for relationships and building them. The whole point is that teacher and student everyone ends up understanding more deeply when students have a chance to talk and to justify their thinking. Thank you, everyone, for being so kind and playing along with us.
I hope that you look to do a puzzle problem in your class next week.
Michael?
Tim, Tracy, thanks so much. As we begin to wrap things up tonight, if you have any last-minute questions for Tim or Tracy, please try to get those asked. They'll do their best to get those questions answered. Earlier, we mentioned that tonight, one lucky winner is going to receive a TI graphing calculator of their choice. And tonight's lucky winner is Rebecca Rowley. So, Rebecca, congratulations. We'll be in touch over email in the next couple of days to give you some more information about that. But again, congratulations, Rebecca.
Congratulations, Rebecca.
To receive a certificate of attendance, please go ahead and click the link that just appeared in the chat window. Along with that is a link for the documents that were used tonight by Tim and Tracy and myself. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. After the webinar, if you still have any burning questions, feel free to give us a call at 1-800-TI-CARES or send us an email, ti-cares@ti.com. Lastly, when you leave the webinar, a brief survey will automatically appear in your browser. Your feedback guides us as we plan future online events, so we really hope you'll share your thoughts in that post-webinar survey. Huge thanks to Tim and Tracy for everything they put together for tonight. I appreciated everything and was on the edge of my seat tonight, so thanks so much.
Thank you for having us.
And thanks everyone for joining us. We hope to see you back online next week. Have a great night.